We are doing mathematics past exam questions, and this is question 1, paper 1, algebra, plus or minus 25 marks. You deserve to get every single mark in this question, and I am nation. These are the topics covered in question 1. Quadratic equations, exponential equations, inequalities, simultaneous equations, nature of roots, and general knowledge. Okay, for illustration, let's refer to these past exam questions. Question 1.1.1, quadratic equation, y, the x is squared. Question 1.1.2, another quadratic equation, y, the x is squared. Question 1.1.3, inequalities, y, we have greater than. Question 1.1.4, exponential equation, y, x is an exponent. Question 1.1.5, quadratic equation, y, you will see later when we remove the square root sign, x is gonna be squared. Question 1.2, simultaneous equation, y, well, they said it, and we have two equations in two unknowns. X and y are being solved. Question 1.3, that's general knowledge question. You see, at the end of question 1, they usually throw in a general knowledge question just to test our basics in maths, like how to do exponents, how to do products, how to apply other topics that are applicable. But sometimes they do throw in some nature of roots questions. So the last question can either be nature of roots or general knowledge. In rare cases, both of them. But all in all, guys, when you practice question 1, paper 1, make sure you cover quadratic, exponential, inequalities, simultaneous, nature of roots, and general knowledge. Let's start with quadratic equations. Question 1.1.1, 3x squared plus 5x is equal to 0. We took this question from this question paper. That's question 1.1.1 for 2 marks. So how do we solve it? Guys, when we solve any quadratic equation, we need to remember that there is a way to start a question, a way to continue a question, and a way to finish a question. Step 1, we're going to make sure we write the equation in standard form, which is ax squared plus bx plus c is equal to 0. Step 2, we're going to factorize. If we don't have the factors, we are just going to use a quadratic formula, which is x is negative b plus or minus the square root of b squared minus 4ac all over, and that's very important, guys, all over 2a. And in step 3, we are going to solve until the end. Here we go. So in this question, we already have our equation in standard form. Y, we can clearly see a, which is 3, b, which is 5. There's no c here. And this is all equal to 0. So step 1, done. We go ahead in step 2 and factorize. In this case, x is the common factor. We take out the common factor from the first term here. Open bracket. What do we have left in the first term? We have 3x left. In the next term, we have positive 5 left. This is all equal to 0. So we just factorized. Step 3, we're going to solve completely. So we write x is equal to 0, or 3x plus 5 is equal to 0. 3x, take 5 to the other side, that's negative 5. Divide both sides by 3. We get negative 5 over 3, and checkmate. Next customer, please. Question 1.1.2. 4x squared plus 3x minus 5 is equal to 0. And in the question, they are saying solve for x correct to 2 decimal places. Whenever they say correct to 2 decimal places, they are suggesting we may use the quadratic formula. Let's go. Remember the process. How do we start? Standard form. So we check whether our equation here is already in standard form. And in this case, it's definitely in standard form. we can see that, okay, A is 4, B is positive 3 right there, and C is negative 5. That is standard form. Then step 2, since they said correct to 2 decimal places, we know we are not going to be factorizing. We are just going to be using the quadratic formula. We are going to substitute the values of A, B, and C in the quadratic formula. Let's start with B, which is 3. Sometimes, guys, B can come already negative, so it's important that you use the brackets in case it's negative. You see, plus or minus the square root of B is back. That's 3. This time is squared, minus 4. A is 4 and C is negative 5. All over 2A, which is 4. Step 3, we just solve until the end. So we use our calculator and start with plus. We are going to get 0,80. That's after rounding off to 2 decimal places. Or the other x value is going to be negative 1,55. That's after rounding off correct to 2 decimal places. And checkmate. Next, this question was quadratic. This one was quadratic. So let's do question 1.1.5. That's another quadratic equation. Remember the process, no matter what they give you. Standard form, factorize, solve to the end. Now this one, guys, is quite unique because you will notice that when you do step 1 standard form, the standard form doesn't have the square root sign. And this question has square root sign. Another thing, the standard form doesn't have fractions. So this one has a fraction. So to write this in standard form, we are going to have to get rid of fractions, and also we're going to have to get rid of the square root sign. How do we do it? Let's start by getting rid of this fraction. So we simply cross multiply in this case. Let's say 1 is 1 over 1. Root 20 minus x times 1. That's root 20 minus x. X times 1. That's x. The fractions are gone, guys. Hooray! Let's get rid of the root sign. We just square both sides. So the left-hand side squared and the right-hand side squared. On the left-hand side, the square part will cancel out the square root sign. And on the left, we are left with 20 minus x is equal to the right side, we simply square the x. We get x squared. See, we are getting somewhere. What's the process? Standard form. Is that in standard form already? Not yet. So we need to take everything to one side and remain with 0 on the other side. Let's go. This is fun. So 0 is equal to x squared. Negative x will become positive x on the right side. 20 will become negative 20. So the usual way of writing it, that's x squared plus x minus 20 is equal to 0. After standard form, what do? We factorize. Can this thing factorize? Let's see. This is a quadratic trinomial, so the factors of x squared, that's x and x. The factors of negative 20, okay, that will be firstly 5 times 4. The signs, we want to get the middle term, which is positive 1x. To get positive 1x, we must say positive 5 minus 4, because 5 minus 4 is positive 1. 5 times negative 4 is negative 20. So factorized. After factorizing, step 3, we are going to solve until the end. So we're going to write x is equal to negative 5 or x is equal to positive 4. But guys, we are not done, because to solve until the end, what does that mean? Well, in the case when we are given the original equation having a square root sign, we're going to have to check our answers, whether they balance the original equation. How do we achieve that? We substitute our answers into the original equation. Do it, use your calculator. Start by substituting negative 5. Let's see if negative 5 is gonna balance our original equation. In the place of x on the left, we put -5. So root 20 minus -5. Let's see whether that's going to give us 1 or not. You will discover that the left-hand side is equal to -1 and the right-hand side remain 1. So -1, there is no way is equal to +1. Therefore, our answer cannot be equal to -5. So we write x is not equal to -5. What about 4? Let's find out. In the original equation, in the place of x on the left there, we are putting 4. Square root of 20 minus 4. Will that be equal to 1? Using your calculator, you will find that the left-hand side definitely is equal to 1. The right-hand side is equal to 1. And 1 is equal to 1. Therefore, x is equal to 4. But x is not equal to -5. And checkmate. Now let's do exponential equations. And I will show you how to start, how to continue, and how to finish the question. In the first option, we are going to do step 1, step 2, and step 3. Like in this question 1.1.4, 5 to the power 2x minus 5 to the power x is equal to 0. This is coming from this question paper. Question 1.1.4 is 4 marks. So if we are following this option 1, this is what we do first. We simplify to get the same base on both sides. Same base. Once the bases are the same, we equate the exponents. Then we solve until the end. Let's apply the steps in this question. 5 to the power 2x minus 5 to the power x is equal to 0. So the bases are already the same, guys, but we need them on both sides. So we have to take the -5 to the power x to the right side. So we write 5 to the power 2x is equal to -5 to the power x will become +5 to the power x. The bases are the same on both sides. Base 5, base 5. Once the bases are the same, we equate the exponents. In other words, we just cancel out the bases. So the exponents 2x and also x are equal. Now we have a simple linear equation, and 2x is the like term of x. Let's bring x to the left. So we're going to have 2x minus x is equal to 0. 2x minus x, that's just x, which is equal to 0. And checkmate. Okay, guys, let's explore option 2, which is the log form. Now, to write in log form, our exponential equation must first be in this form. Why? Because when we are solving for x, and x if it's an exponent, we just say an exponent, which is x, is equal to a log. And once a base, always a base. So the base in exponential form, which is a in this case, will be the base in log form. So x will be equal to log, when the base is a, is going to be the log of b. Let's take the same question 1.1.4, which is this one, and write it firstly in this form. Let's see, how do we do it? So many ways to do it, but what I see immediately here is that, okay, we have two terms, guys. So this is term 1 right here, and this is term 2. And in maths, whenever you have 2 or more terms, you have to check whether factorization is possible. In this case, I see there is a common factor, which is 5 to the power x. To see it more clearly, let's write 5 to the power 2x as 5 to the power x times 5 to the power x minus 5 to the power x is equal to 0. So the common factor is 5 to the power x between these two terms. We take out 5 to the power x as the common factor. What do we have left in the first term? We have 5 to the power x left. Minus, in the next term, we just write 1. This is all equal to 0. Then we say 5 to the power x is equal to 0, or 5 to the power x is equal to, take -1 to the other side, you get +1. And you see, both equations are in this form, and that can be converted into log form. Let's do it. We are solving for an exponent, so an exponent, which is x, we equate it to a log. And what do we say? Once a base, always a base. So the base is 5. This empty space will be 0. And in this case, since we don't have a log of 0, your calculator is going to give you some error right there. So in this case, we're just going to say, okay, no solution. Or even better, you can just write 5 to the power x cannot be equal to 0. The other equation, let's convert it into a log form. An exponent is a log. Once a base, always a base. The base is 5. We write it on the base of the log. The empty space, we write 1. Use your calculator. Log of 1 to any base, the answer will be 0. And by the way, even without using the log form, if you have 5 to the power x is equal to 1, you can still make 1 to be 5 to the power 0. If you are going with option 1 of same base on both sides. Because 5 to the power 0 is 1, and the bases are the same, then the exponents are equal. So x is equal to 0. And checkmate. Let's talk about inequalities, somebody. Inequalities, we are referring to greater than, less than, greater or equal to, less or equal to. And if our solutions are going to be written in brackets form, greater than and less than, we just use the normal brackets. Greater or equal to, and also less or equal to, we use the square brackets. Normal brackets represent not included. Square brackets, that's included. For sure, there will be a lesson explaining more on that. So when we do inequalities, I'm going to be showing you how to start the question, how to continue, and how to finish the question. That's step 1, step 2, and step 3. And in step 1, we're going to write in standard form. Standard form can mean let's have a 0 on one side. And step 2, we factorize. We're going to factorize where applicable. Step 3, we find the critical values. Then we do graphical representation, which can actually be a graph, which is a parabola like this, or just a number line. After graphical representation, we write down our solution. By that I mean answers. Now from this question paper, let's do question 1.1.3. This one, 4 marks, inequalities. 1.1.3. How do we start? Standard form. Our standard form, if our equation is quadratic, and in this case it's going to be quadratic because we know when we remove the brackets, the x is going to be squared. So we're going to have to write our standard form as a quadratic standard form. X will be squared. Then we multiply everything we see. 2 times x times negative 1, that's negative 2x. Then we square the negative 1, which will be positive 1. Not forgetting minus 9, greater or equal to 0. This is not yet standard form until we add the like terms. So x squared minus 2x, 1 minus 9, negative 8, greater or equal to 0. This is now in standard form. Step 2, can this thing factorize? Let's find out. Factors of x squared, that's x and x. The factors of negative 8, when we add them, we must get negative 2, the middle term. That's 4 times 2. And the signs negative 4 plus 2 will give us negative 2. Negative 4 times positive 2, that's negative 8. Step 3, critical values, then graphical representation, then answers. So the critical values, when we solve here, we get the critical values. X minus 4, we are getting x is equal to positive 4. The other critical value, x is negative 2. Now graphical representation. It's either we use the number line or the graphical method. I'm going to go with the graphical method here because it's just straightforward. My opinion. Now here guys, whenever we do the graphical method, we have to consider the standard form. In that standard form, we have positive x squared. In other words, a is a number which is greater than 0. In other words, it's positive. So if a is positive, we know our parabola is going to smile. Why parabola? This is a quadratic expression. So we draw a quadratic function. And it's smiling, no joke, because a is greater than 0. We draw this line here and plug our critical values. We start with the negative number, or rather the smaller number on the left. So negative 2. The right side we have positive 4. Next we check the step before the critical values. which is the factorization step. And from that, we can see we have a greater than 0. Now, imagine this line right here. Okay, let's call it 0 line. And greater than 0 means our solutions, our answers are above the 0 line. That's greater than 0. So we are talking above from positive 4 like this, going to the right side, or from negative 2 going to the left side. So let's write down the answers. We're going to write, okay, x is right from negative 2 to the left side. To the left, we use less than. And our inequality has an equal sign. So we're going to write less or equal to negative 2. Or our solution is also found right from positive 4 to the right side. To the right, we use greater than. So that will be greater or equal to positive 4. And checkmate. Let's do some simultaneous equations, somebody. Now, when we do simultaneous equations, we need to understand that they're going to be giving us 2 equations most of the time. Not all the time, but most of the time, we are given 2 equations. One of them must be linear equation. So that's equation 1. The other one will be quadratic equation. Like in this question here, we have equation 1, which is linear, and equation 2 is quadratic because we have some squares here, x squared and y squared. And guys, sometimes we are actually given equation 1 not yet in linear form. For example, let's say you are given 2 to the power x plus y is equal to 2 to the power 9. You see, it's in exponential form, but we must make it linear. How? By making sure we have the same base on both sides. And if we have the same base on both sides, therefore exponents are equal. And we say x plus y is equal to 9. So let's be ready, guys. Sometimes equation 1 will not be in linear form yet. It can be in exponential form first or in other forms. Now, once we get equation 1 linear, and we have quadratic equation as equation 2, what do we do? What's the process? If we are using substitution method, in step 1, we are going to make equation 3 from equation 1. Step 2, we substitute equation 3 into equation 2. Then we solve. Step 3, we take the answers from step 2 and substitute them into equation 3. Check this out. Equation 3 is found in every step. 3, 3, and 3. We are going to apply those 3 steps in question 1.2 right here. 5 marks. So this is equation 1, which is linear. Step 1, we make equation 3 from equation 1. We can choose to make x the subject of the formula or to make y the subject of the formula. Whatever makes us smile, guys. I choose x. So x is going to be equal to 9 minus y. And that's equation 3. And step 2, we substitute equation 3 into equation 2, then solve. In equation 2, where we see x, we are going to be putting everything here in brackets, guys. Substitution must rather be done in brackets. So in equation 2, we are starting with 2, and in the place of x, we are writing 9 minus y, not forgetting to square it because in equation 2, the x is squared. Minus y squared is equal to 7. Let's remove the brackets. Let's start with the square part. 9 squared, 81. 2 times 9 times negative y, that's negative 18y. Negative y squared, that's positive y squared. Let's close the bracket. Outside the brackets, we have negative y squared is equal to 7. Let's remove the brackets completely. 2 times 81, that's 162. 2 times negative 18y, that's negative 36y. 2 times y squared, that's positive 2y squared. Then we still have negative y squared. That 7 on the right hand side looks so lonely. Let's bring it over to the left hand side. It will become negative 7 is equal to 0. After removing the brackets, we look for the like terms and we got them. 2y squared minus y squared, that's y squared. Negative 36y is just alone. 162 minus 7, that's positive 155. What do we have? Our lovely quadratic standard form. And after standard form, we factorize. Can this thing factorize? Let's find out. The factors of y squared, that's y and y. The factors of 155, that's 31 times 5. We want to get the middle term, which is negative 36. We can achieve that by saying negative 31 minus 5. Then we say, therefore, y is equal to 31 or y is equal to 5. Step 1 done, step 2 done. Now step 3, we are going to substitute our answers into equation 3. Equation 3, where are you? This is equation 3. Now where we see y, we are going to write 31. So that's 9 minus 31. Or where we see y in equation 3, we are going to write y is 5 there. Or where we see y in equation 3, we're going to put 5, the other y value. So x is equal to 9 minus 31, that's negative 22. Or x is equal to 9 minus 5, that's a 4. And checkmate. General knowledge questions. In question 1, paper 1, the last question is usually general knowledge, like this one. Question 1.3 for 3 marks. So in general knowledge questions, guys, the examiners just want to test your algebra skills. Skills like factorization, products, whether you can work with fractions, exponents, surds. All in all, guys, you are just applying any topic or concept in maths. That's your general knowledge. Like in question 1.3, we are given P and what it is equal to, and also T and what it is equal to. They want us to determine the value of P times T. So that's some products happening here. So we are multiplying P by T in terms of A. So our final answer must contain letter A. How do we do it? Let's see. They are saying find P times T. So here P is 1 minus A and T is all that. So since the aim is to simplify, not necessarily to expand, guys, we have to check what concept is displayed after multiplying P by T. What I see here, look at this. Check the first 2 factors here. What do they look like? They look like the difference of 2 squares. That's factorization. You remember that, guys, in maths, when we factorize the difference of 2 squares, we are given something like this. Let's say a squared minus b squared. So these two are the difference of 2 squares because a squared, b squared, and we have a minus which stands for difference. So to factorize this, we are going to have to write it as, firstly, a minus b. That's the square root of a squared is a. The square root of b squared is b. We write minus, and in the second brackets, we just change the sign. So if a squared minus b squared can be written like this, we can also reverse the process and write it back to that. Like in this case, 1 minus a into 1 plus a, that can be written as 1 minus a squared. You see, 1 is a square number, a squared is a square number. So everything in the red box is becoming 1 minus a squared. Let's write what is left. After that, we continue checking what we have displayed here. Check this out, guys. We have another difference of 2 squares. Check this out, guys. We have another difference of 2 squares. You see, 1 minus a squared, 1 plus a squared can be written as 1 minus a to the power 4. When you factorize 1 minus a to the power 4, you will get everything in the green box. The difference of 2 squares. Let's write what is left. Once again, guys, everything in the red box here, that's another difference of 2 squares. 1 minus a to the power 4 into 1 plus a to the power 4 can be written as 1 minus a to the power 8. So when you factorize 1 minus a to the power 8, you're going to get everything in the red box. Let's write what is left, which is 1 plus a to the power 512. Can you see the pattern going on here so far? Right from the top there, we have a to the power 1, a to the power 2, a to the power 4, a to the power 8. So a to the power 1, 1 times 2. So a to the power 1, 1 times 2 is a to the power 2. Times 2 is a to the power 4. 4 times 2 is to the power 8. Times 2 to the power 16. Times 2 to the power 32. Times 2. Eventually, guys, we will end up arriving at a to the power 512 because there are some factors in between here. So at the end of the day, even 1 plus a to the power 512 will get a chance, which will look like this. It will have a partner which is 1 minus a to the power 512. And what's 1 plus a to the power 512 into 1 minus a to the power 512? That's the difference of two squares, which is 1 minus a to the power 1024. And there we have it. At the end of the day, p times t is going to give us 1 minus a to the power 1024. That's the general knowledge. What did we apply here? We applied products, we multiplied, but to simplify, we were applying the difference of two squares. And checkmate.